customary for speakers to announce when you're in the last session that this is the graveyard talk. So I think it's quite important for me to do that. It's also customary to introduce yourself. So maybe I should start with my name. My name is Nhlanhla Lucky Nkosi. Yes, that does mean that I have two names that mean the exact same thing, just translated into different languages. I do many things. And I come from a very diverse background in terms of tech. And all of that started by me studying at WITS and studying this very obscure thing called game design, which has led me to becoming a professional developer, I guess, in inverted commas. And because I suffer from a bit of Stockholm syndrome, I've also gone back to teach at WITS. And as the new slogan says, for good. What they mean is that you are there for good. I've taught game design and I currently teach computer science there. I've also done a couple of things. I tried helping our government for a couple of years as something called a social cohesion advocate. Very fancy words, don't ask me what we did. And I also do some work with a number of foundations and nonprofit organizations across the country. One of my core passions lies in building community, especially tech community. And so I've been involved with a number of meetups through the years. My favorite being Josie.js. We'll bring it back one day. You can forget everything I've said to you, because the most important thing for you to know about me is that my X handle is at nlucky_Nkosi. It pains me to call it X, but this is what we have, and so we go along with it. When I'm not doing everything that I just spoke to you about, no, we don't. When I'm not doing everything that I just told you about, I have a job, and I work for a company called BBD. And much like my very good naming convention, BBD is named after our three founders, Baron, Budge, and Dominique. Sounds like a law firm. That's because the company was created 40 years ago. It says 39 plus because we only turned 40 in September. It was started in Sandra's garage, and we've now grown to be a bespoke software house that's found across the world with almost 1,300 people, proudly calling themselves BBDers, rather. My job, though, at BBD is slightly different. I'm the head of a division called ATC, which is responsible for BBD's research and development functions. On paper, we also say we do specialized consulting, and we're also responsible for facilitating learning, as we call it, because we don't really teach. We just sort of like tell everyone else in the company, you should all go and learn this. And we give them links and they go and learn it. But when you're in an organization as big as this, I say big and big is relative, that has been around for such a long time, it means that you have a very, very diverse group of people. And this diverse group of people have very diverse skills. My skills in particular come from game design, of course. This means that my training, my formal training, was with languages like C#, C++, assembly. And so when I became a professional developer and I joined a corporate like ours, I didn't really have a sense of what type of developer I wanted to be. Unlike most people that do computer science, that want to be a back-end developer or a front-end developer. I didn't have any of that. So I was really happy to get anything that they would give me, right? Whether it was JavaScript or C#. So when the wars between back-end and front-end came about which one is easier, best, I was just there in the middle, man, just like happy to be here. I was just like the derpy junior, just like, I just want to code. And the result of this is that I was then dragged into very old projects. One of my first projects was, at the time, it was probably almost 20 years old, a 20-year-old project that had C++ and C# backend, and the front end was built with something called VB6. Spent a couple of years on that. I was like, oh, cool, we're coding. And then I was told we need to upgrade this to work in the web. I Googled how to web. Simple answer. All you need is HTML, CSS, and JavaScript. I was like, right on, right? This is great. We can build these things. And so Being the expert developer that I am, I built my CV website, right? Portfolio website. I was like, look, I am now a front-end developer. Someone said, no, that's not how you do it. You need to use a framework. I won't give away my age, but the framework of the time was AngularJS. And they said, you have to use AngularJS. 3 months later, I was told, actually, you should be using React. Which means that I looked down, I tried to look at React and what it does. When I looked up, I found this. And I was overwhelmed. I was truly overwhelmed. But you know, we pretend. We pretend that we get it. Everything's okay. But there's this constant nagging feeling at the back of my head saying, surely I'm the one that's doing something wrong. This can't be the reality of this ecosystem that has such an impact on users everywhere else. And so I figured, since I'm doing something wrong, let me reach out and look at the community. Because if I'm doing something wrong, the community will be able to guide me and show me how to do things properly. I looked for a community, and I found it. I found a community of developers as unhinged as their technology. I mean, I'm talking about a really unhinged community. One that created a metric ton of scripts and frameworks and libraries to do everything. My favorite is a library on NPM called isPositive. It tells you whether a number is positive or not. And one called isNegative that imports isPositive and uses that to tell you whether a number is negative or not. At this point, I'm thinking, how on earth did we get here? How did we go from just HTML, CSS, and JavaScript and get to this chaotic space that we're in? And so today I'd like to bring you the results of that question by taking you through the evolutionary tale of the web. To understand this, first I need to set your expectations. Because every single person I've told what I'm going to talk about today, they've gone, you can't do that. So you'll see PowerPoint animations, much like this one that you just saw, quite a few of those. Because I'm young, the history will be secondhand, partially ChatGPT generated. For those of you who are old enough to have been there during the days of Netscape, like one of the speakers in the speaker holding room, expect some nostalgia. I won't mention any names. Rob. One or two memes. Just a few. And maybe, just maybe, you might learn something that you didn't know before. But if you do, that's probably very accidental. It wasn't my intention. What you will not be getting today is 100% historical accuracy. You also won't be getting 100% coverage, because if I were to talk about the history of the web, it would take me a very, very long time, much longer than the 31 minutes I have left in my clock. Let's begin in the beginning. That's generally a good place to start. Let's take it to the year 1990. Sir Tim Berners-Lee, I think that's how you say his surname, right? So around 1990, he is credited with creating the World Wide Web, and along with it, HTML. And the first web page goes live in August of 1991. That's what it looks like. Revolutionary. Links everywhere. This has been restored, and you can actually access it. This is a screenshot that I took last night. Around that time, or a couple of years later, once people are starting to build these different web pages and web browsers, one such was called Netscape. Netscape realizes that they need to add some sort of programming functionality to these web documents. And so they plan to have Java as the language that you create these incredible web pages with. They very quickly realize that maybe that's not the best idea. They move on to plan B, which is to call this man, Brendan Eich, and ask him to build a language that they can use. He asks when, they say, actually yesterday. And so 10 days later, he comes up with a language. He calls it Mocha. They realize, no. Mocha doesn't sound too cool. What about LiveScript? Before eventually settling on JavaScript, for the best reason ever. Because they wanted JavaScript to sound like the cool cousin to the very popular and awesome language at the time known as Java. But okay, we know that Java is, or car Java is to JavaScript what car is to carpet, rather. Right? They've got absolutely nothing to do with each other. And at this point, we now have HTML, CSS, and now we have JavaScript. These three technologies allowed companies, formidable companies, to form and build websites that look like this. Oh, and one cool thing that JavaScript did was give them pop-ups. So many pop-ups. Pop-ups everywhere. The world is a beautiful place. We have now built the tools we need to build everything on the web. A trinity, if you will. But because of the increased consumption of media through the web, developers start realizing that we need a lot more moving parts to keep people's attention and to make it entertaining. And the term DHTML, or dynamic HTML, starts being coined or starts being used to describe using JavaScript and CSS to create more animations. After bravely surviving the year 2000, the world's population starts using the internet significantly more. And with this demand, or this use, comes the demand for even more features in the browser. Users want more stuff. And the JavaScript developers want to give them more stuff. The only problem is that at this point, every single interaction on the web requires the fetching and rendering of an entire HTML page. So the tiniest interaction would require your browser to go and get a whole new document, parse it, render it, and show you the entire thing. None of this dynamic stuff that you have now that's making you lazy. So this process was very inefficient, and it reflected really badly on the user's experience. The browsers needed a way to be able to fetch data and updates without interfering with the user interface. And so Google came up with something called AJAX. Not this one. This one. AJAX is in asynchronous, JavaScript, and XML. Yes, that's what it stands for. Now, this was widely used by Google. Is that my calendar? Oh, no, it's not. Now, this was widely used by Google in Gmail and on Google Maps. And what this did is that it allowed the browser to go and make calls at the back to a web server to get data and then update the browser with the data that it got. Today, the term AJAX refers to a much broader group of technologies that make this exact same thing possible. Now, AJAX was a massive game changer. It changed the way we built the web forever. But there were issues with it. Things like browser compatibility, complexities, and now the use of this AJAX actually requires us to think back just once more to Brendan Eich. You see, when he created JavaScript, he also created the first engine to run it. Does anyone know what this engine was called? SpiderMonkey. He created an engine called SpiderMonkey to run this JavaScript, and this wasn't the only one in the 90s either. Microsoft, which was a rogue faction of developers, built their own clone of JavaScript with its own features to run it in Internet Explorer, which meant that by the late 90s, it was so far off from JavaScript and had so many compatibility issues that Internet Explorer would haunt developers for decades after that. Mozilla built something called Rhino, completely in Java, right? And what Rhino would do is that it would try and convert JavaScript into Java bytecode. So this was the first attempt to make JavaScript run a bit faster. Rhino wasn't the last solution that tried to convert one language into another. Around 2006, Google released something called Google Web Toolkit. Now, this allowed developers to write front-end code in Java. It would then convert this to JavaScript. And this brought strong typing and object orientation, and people are like, the web is becoming very, very serious. CoffeeScript, around the same time, came in. Now, this added syntactic sugar, or syntactical sugar, on top of JavaScript, and it would allow you to write much more readable and concisely syntactical JavaScript. And then this would then compile or transpile down to JavaScript. Sounds familiar, right? Sounds like TypeScript, but back in the days. This was awesome, and Google contributed to this. But at the same time, because of how much JavaScript Google was starting to ship to the browser, they realized that they can't actually keep growing their solutions without changing the underlying infrastructure. And so they invested a lot of R&D work and budget, and they came up with the V8 engine. The V8 engine, again, tried to run JavaScript just faster. It came with significant performance enhancements, and its just-in-time compilation strategy changed the game forever. What did it do? So it took JavaScript and compiled it straight down to native machine code, which meant that there was no need for any intermediate step, which made running all of this faster. It didn't need any intermediate bytecode, and there was no interpretation like its legacy predecessors. V8 also had something called adaptive optimization. So instead of trying to optimize all of the code, it would run a much lighter version of it, quickly generate some non-optimized code, and run it. And as it executes, it would find those critical parts. So the code that gets executed a lot, it would identify that and then recompile it into much more optimized machine code. And then this would actually help it go faster. Lastly, it had a really, really good garbage collection strategy. So it would do something called incremental mark and sweep, which meant that you had way less pauses due to garbage collection with this new engine. It's amazing. They have the Chrome browser, and things are starting to look good. One developer in particular, his name is Ryan Dahl, gets inspired by this. And while he's annoyed by Apache HTTP servers, decides to build on top of this and create something called Node, allowing JavaScript to be written in the backend. And now you had JavaScript developers writing backend code. Now, at this point, the web is starting to be taken seriously, and JavaScript as a language is starting to be taken seriously. A couple of problems start arising. The solutions we build are getting really big. There's so many dependencies, so many libraries. We need to know whether numbers are positive, so we need to import the isPositive script. There's so many dependencies, and making sure that they all get linked at the same time, that we have all of the dependencies, is starting to become a problem. At the time, linking these scripts or including them often required us to have a script tag in our HTML page, and making sure that they all download and run in the correct order is becoming a problem. Similarly, ECMA or ECMA is waking up from a 10-year-old slumber, and they're starting to create standards for JavaScript, which obviously is going to start bringing backward compatibility issues, especially with Internet Explorer. Developers needed a way to solve all of these problems. They needed a way to make sure that in the development space, we could write code using the paradigms that we're familiar with, separate our code into the different files, etc. But when we then go to production, we're able to clean those up and have less files. Because downloading tiny little files, multiple of them, is actually really poor or causes poor performance. And so module bundlers came into play. Some example of these include things like Webpack, Parcel, Rollup, and Browserify. And what these do is that they take all of the code that you have in your development environment, and they actually package it for you in a way that will make it much faster to productionize. And this led to a significantly better developer experience. Now, the concerns around developer experience are not just in performance and with JavaScript at this time. These concerns also relate to how we actually structure our code, to the CSS stuff around the styling, as well as the HTML. And there's a lot of JavaScript code that we write that helps us specifically with the user experience. And so in 2006, John decides that he is tired of rewriting all of this JavaScript code repeatedly that does the exact same thing each time, and he creates jQuery, the legend. jQuery at this point is created so that all of these repetitive JavaScript lines of code can be written in one line. Takes it, encapsulates it with the goal again of one line. $sign here and there, but one line. At this point, jQuery is fast and it enjoys a lot of popularity. It made traversing HTML documents much faster and easier. We could manipulate them easier. It dealt with things like event handling, animations, and of course, getting that data back through your AJAX calls. By 2010, jQuery was found in about half of the world's site. That's how incredibly popular jQuery was. One of the cool things about jQuery is that it allowed for other developers in the community to extend it. And so we saw two variations of it or extensions of it being officially released and endorsed, one called jQuery User Interface and one called jQuery Mobile. You'll notice that this is around 2010 when cell phones really start taking up. Until today, we see some of the thinking behind jQuery in how it dealt with DOM manipulation and the data actually influencing even some of our most modern frameworks. So while John was trying to make JavaScript and HTML better, CSS fanatics were not sleeping either. We saw the creation of SAS, which stood for Syntactically Awesome Style Sheets. Now here, you can tell this was created by JavaScript developers, maybe Python, because they decided to get rid of curly brackets and use tabs. Change the syntax entirely, which caused issues with people that were writing CSS, because now they actually had to learn something new. A couple of years later, it was followed by SCSS, which was a superset of CSS, which meant that any valid CSS would be considered valid as CSS. These two introduced things like CSS variables, which made writing modular and reusable CSS that much easier. While we were busy hosting the world's greatest World Cup ever, a company was growing. In addition to worrying about what the blue bird should look like, they were actually growing in terms of their user base and the features that they were putting out. There's one problem with that all of these different teams that were actually doing things in their own different ways. And the code base at Twitter was becoming chaotic. And so two developers sat down and they said, let's actually create something that's going to help the rest of the development teams have some sort of consistent styling and some sort of consistent conventions. And so Bootstrap was born. And Bootstrap, much like jQuery, took over a big chunk of the space. Bootstrap had a set of, or provided a set of CSS and HTML conventions to make all of this easier. But one of the really cool things that it did is that it introduced grid layouts, giving developers the strength they needed to leave HTML tables for styling and actually use some CSS. This was particularly important because a few years before that, a man in a turtleneck changed the way we interact with technology forever. Smartphones were growing. They were growing significantly, and the need for responsive design was becoming more and more apparent. So Bootstrap started playing a massive role in web development projects in order to enable this. While Bootstrap was built out of Twitter to solve their problem and then grew into a community, another framework was created called Foundation. How many of you have heard of Foundation? I see 2 hands, 3. Foundation was created ground up as a response to Bootstrap, to say, let's actually do it ground up and try and fix all of the problems that we see there. Needless to say, it didn't gain the popularity that Bootstrap did. But at this point, Foundation was actually one of the first frameworks to be integrated into AngularJS. Speaking of which, Google is still obsessed about the idea of having one page and fetching data and changing the page. Everyone's like, no, but PHP, Ruby on Rails, you could just run. Google's like, no. The page must be there. It must fetch its data. So while we're busy teaching the world about etiquette of using vuvuzelas, Google is working, and they release AngularJS. AngularJS becomes a tool set. Out of the box, it comes with a development environment with things like Gulp, where they're able to provide some linting to guide you on how to do it properly. They're able to be much faster. It comes bundled with other dependencies that we've spoken about. So it's released by Google in 2010, and it allows developers to write much faster applications. It provides an extensive extension to things like HTML as well. So it's built around the belief that declarative programming should be used for building the user interface, and that imperative programming is better suited for defining the logic behind that interface. It came with two-way binding. For me, I think this is what sold a lot of developers. For the first time, I could change a variable and the screen changes. I don't have to go and say, find this document element, .inner HTML, and then chug it with a lot of string to change what it looked like. I just changed a value in my variable and automatically changed. This was massive game changer. It came with directives that enhance HTML's capabilities by giving it extra and new attributes. It provided dependency injection, which means that we could be much more strategic about how we use our resources, thereby enabling things like services, which are very common in modern-day frameworks. It came with a lot of benefits. We saw quicker loading times, improved user experience, and we saw rapid front-end development because there were a lot of these tools or out-of-the-box templates that you could use. It also had a really good caching strategy, or caching abilities, rather. It wasn't the only one. Right behind it was also something called Backbone.js. Much less prescriptive because some developers were hesitant to take on a framework like Angular that says, you will build it like this. So Backbone said you could use this along with anything else that you might want. A developer, Yehuda, who had worked with jQuery and I think the Rails project, also released something called Amber. Now, they all had their spaces and their places in the ecosystem, but Angular really, really took off. But it had problems. It had problems with things like state management, and it had problems when the applications got really, really, really large. One such large application was Facebook. What probably started as an extraterrestrial research experience, trying to figure out how humans think, it really grew into a massive UI-intensive application. And influenced by something called XHP, some of the developers there, or Jordan, created something called React. React changed how they saw different elements on the page. They saw them as components, so they introduced component-based architecture. And this allowed for reusable UI components. They introduced the idea of a virtual DOM, where instead of changing the document object model itself directly, they would change it on this virtual DOM, minimizing how frequently they would need to change that extra one. And that came with incredible performance benefits. It introduced JSX, which looked like you're writing HTML, but really it's just JavaScript. At this point, these two were growing, and they were starting to build their own factional communities. Some preferring Angular, others preferring React. And the problem with Angular is that even though it had all of these tools out of the box, when it really, really grew out, if not looked after properly, it would start becoming slow. And we all know that developers always learn how to use their tools correctly, right? And we also know that all the juniors that we put on our projects learn the fundamentals before using the tools that we have. So while AngularJS offered a much more complete package, React focused on the UI layer and allowed you to plug in anything else that you wanted to use along with it. The Angular team recognized the problems that they were facing, and they decided to fix them, the best way to fix broken software. Took it out the back, and they burnt the entire thing. They rewrote the entire framework using TypeScript. They said, these JavaScript developers must learn types. Here's a language from Microsoft, TypeScript. They're going to use it properly. They also introduced components. They leaned into this idea of component-based architecture. And the new Angular, or Angular 2+, started becoming really, really fast, competing with React even. It also came with other things, like a CLI, which means that Angular developers could now also sit at a coffee shop and pretend to be doing something super important, like in the Matrix. Life is bliss. You've got frameworks that deal with performance, that deal with UI, responsiveness, and these frameworks use the underlying tools that we talked about. They use the bundlers like Webpack to create good developer experiences. The world is great. One of the developers that worked on the Angular project, even you, decides he wants to take the parts that he liked out of Angular, make them lighter, and build his own thing called Vue.js. And after this, we see a number of other frameworks that we use today that are built on taking the different elements of different architectures and different preferences and different strategies in order to build web solutions in their own opinionated way. At this point, because of the popularity of these frameworks, we have people building very simple CV websites with the heaviest of tools. And so static site generators start popping up. Static site generators like Gatsby and Hugo that allow you to be able to generate these sites from raw data like JSON and Markdown files. We did it. We built a stable ecosystem. Or did we? One of my favorite quotes from Jeff Edwards says, any app that can be written in JavaScript will eventually be written in JavaScript. He shouldn't have said this because JavaScript developers have taken this very seriously. We saw the wars between Android and iOS and thought, what about us? And so new frameworks started popping up, aimed at building native apps. Said, no, we're going to build it in JavaScript and we're going to run it natively, right? And so we start seeing this pop-up of these frameworks that try to do that. But now that we have these, we're done, right? Of course not. We thought, but what if our websites are already apps? And so we created progressive web apps, where we created websites that pretended to be apps, that looked like apps, that tried to behave like apps, right? And the story doesn't end there. There's new tools coming out every single day. Tools that help you check if numbers are positive, if a string is really a string, all of these things. And with developers now forming their own different opinions, right? Whether they want to render it on the client, whether they want to render it on the server. Even how many websites to have in their own website with things like micro frontends and module federation. The point is that the 2010s or the 2000s and the early 2010s have now given us the tools, the core tools we need to build great experiences. So while it's impossible for me to give you the full extensive history of everything there is to know about the web, I'm really hoping that knowing that I've given you the fundamentals of why we have the things that we have today. And knowing these fundamentals, I hope that the next time you see an image like this or try to figure out what tool to use, you're not overwhelmed by all the jargon that's thrown at you. Next time you get into an argument, don't let them intimidate you. They're probably just using some of these very, very fundamental core things to sound great. My name is Lucky Nkosi. Thank you very much.